Hi, grade 10s. In our last lesson, we were learning about how we could figure out the formula for an ionic compound. But there are easier ways than drawing all of the Lewis structures and moving the electrons. And there's a little song and dance that we can do to figure out how to do a formula for an ionic compound. And it's the symbols, the charges, the crisscross, reduce. And if you were in class with me, you'd see me dancing for that. Symbols, charges, crisscross, reduce. So for example, if I want to do magnesium and oxygen, the symbol for magnesium is Mg, and the symbol for oxygen is O. So I've done the symbols, Mg and O. Then I do the charges. The charge on a magnesium is +2, and remember the spot for charge is the upper corner. The charge for the oxygen is -2. Again, charges go in the upper corner. Symbols, charges. Our next step is crisscross. We call it crisscross because we're going to make an X. I'm going to take this 2 and slide it down here to the how many spot after the oxygen, and this 2 and slide it to the how many spot after the magnesium. Watch the 2 go sliding down here, and this 2 goes sliding down here. So when we do this, we don't bring the charges with us. So basically, what you're going to see is just Mg2O2. We need 2 magnesiums for every 2 oxygens. But here's a great place where we can reduce. 2 and 2 are both even numbers, and so we can reduce that to a 1-to-1 ratio. In other words, Mg O. So this last step, the reduce, is an optional step, and it won't happen every time. All right, symbols, charges, the crisscross, reduce. Here's my little stick man dancing figure. Let's try magnesium fluoride. Symbol for magnesium, Mg. For fluoride, I know that comes from fluorine, that's an F. Now I'm going to take those symbols and I'm going to figure out their charges. So remembering that we have magnesium and fluorine, magnesium is in group 2 on the periodic table and has a charge of +2. Fluorine is in group 7 on the periodic table and has a charge of -1. So I've written those in the charges position. Step 3, the crisscross. In the crisscross, we take just the number and write them down and towards the other element. So, remembering we have Mg and F, we're going to take the 2 from the magnesium and write it down after the fluorine, and the 1 from the fluorine and write it down after the magnesium. There's not so much a reduce here as a simplify. We don't write the number 1s in chemistry, but we do have to write if there's any other ones. So this is MgF2. We would name this magnesium fluoride. Symbols, charges, crisscross, reduce. This works as a much simpler way to figure out the formula for all ionic compounds. Let's try using that formula on this short little assignment. This would be a great place to pause the video and try on your own, and then once you've tried, come back and see how you did. Pause the video here. All right, how'd you do? So for aluminum and chlorine, I've started it for you. Aluminum is in group 3, has a charge of +3. Chlorine in group 7 has a charge of -1. So we've done symbols and charges. Now we'll crisscross. So after the aluminum, I'm going to put the number 1, because that was the number that came after the chlorine. And after the chlorine, I'm going to put the number 3. So these are down in the how many position in the bottom right-hand corner. Simplifying, because we don't write the number 1, AlCl3 is aluminum chloride. How about aluminum phosphide? Again, we know aluminum has a charge of +3, and phosphorus, phosphide comes from phosphorus in group 5, has a charge of -3. So when I crisscross, when we take this 3 and write them down in opposite, they trade elements here. we're going to have Al3P3. And because these can both be divided by 3, we can reduce this to ALP, aluminum phosphide. One more, magnesium oxide. Magnesium +2 charge, oxygen -2 charge. We crisscross just the numbers, they go to the opposite element. So we have Mg2O2, and we reduce that to MgO, magnesium oxide. So there is a task following this that I would like you guys to try to see how you can do with coming up with the names and formulas for ionic compounds. Once you've tried that task and had a chance to check it out, I want to try explaining what we do, however, when the metal comes from the central section, the transition elements. My transition metals that we have here in the middle are kind of an interesting group because these guys can have more than one charge. And we never know which charge they're going to pick. Sometimes they're going to pick one charge and another time they're going to pick another one. Like all metals, they will always have positive charges though. These guys are always going to form cations. So for example, iron, right here, Fe. Sometimes iron likes to take a charge of +2. Sometimes it likes to take a charge of +3. But copper sometimes likes +1 and sometimes likes +2. All of these elements can take multiple possible charges that you will find on your periodic tables. But if I tell you to make a compound like iron and oxygen, which iron do I pick? These elements are called multivalent because they can have more than one valence, more than one set of charges. They're still ionic, however, because they're going to be a metal and a nonmetal, and all ionic bonds are formed between metals and nonmetals. We're still going to do the symbols, the charges, the crisscross, and the reduce. The difference, however, is that for my transition metals, we have to tell you which charge to pick. And the way we tell you is by using a Roman numeral. So if I want to do iron and oxygen, the symbols for iron and oxygen are Fe and O. But we already know that iron can sometimes be +2 and sometimes be +3. How do we know which one to pick? You'll notice after the word iron here, I've included the Roman numeral 2. That means we're going to pick the charge that matches that Roman numeral. If I have Roman numeral 2 here, I'm going to pick the charge that's 2. Had I said iron with the Roman numeral 3, then I would have picked iron whose charge is 3. So the name will have Roman numerals because Roman numerals are letters and names never have numbers in them. But the name will include a Roman numeral to tell us which charge to pick. Now the charge on oxygen is always -2. My tall columns only get one charge each. Now I crisscross to get Fe2O2 and reduce, and I get the formula FeO. When I name compounds like this, the metal gets its normal name, but the metal, if it's a transition metal, has to come with a Roman numeral. And the Roman numeral tells us which charge we picked. So I can't just call it iron oxide. I have to call it iron 2 oxide. What I want us to remember is that all transition metal names, the names only, come with a Roman numeral, not any other kind of number. If you don't remember how to do your counting in Roman numerals, I've included a quick refresher for you right here. So Roman numerals go in the name to tell us which charge we used. FeO was formed from iron 2. This is iron 2 oxide. We won't use Roman numerals for anybody except for transition metals. So let's try doing the formulas and the names for these two examples. Let's try doing lead-4 and oxygen. So the symbol for lead is Pb. The charge on the lead comes from this clue in the Roman numeral. That's the Roman numeral 4. So the charge will be +4. Oxygen symbol is O, and its charge is -2. When we crisscross, we get Pb2O4. This 4 comes after the oxygen, and the 2 now goes after the lead. We have to reduce this, PbO2. What would be the name for PbO2? Well, this was formed from lead, whose charge was 4, so lead 4, and oxygen becomes oxide, lead 4 oxide. Lead comes with a Roman numeral because it has more than one possible charge. What about cobalt-3 with chlorine? Cobalt is big C, little o. Its charge would have been 3, always positive because it's a metal. Chlorine is Cl, and his charge is -1. When we crisscross, the 3 will come down after the chlorine, the 1 will come down after the cobalt. We're going to need 1 cobalt and 3 chlorines, COCl3. Again, we don't write the number 1 in chemistry. It's just cobalt chloride written this way. But which cobalt did we use? His name, because cobalt has more than one charge, has to include a Roman numeral. This was cobalt whose charge was 3, cobalt-3 chloride. Again, if the metal has more than one charge, then the name must include a Roman numeral in it. You'll notice there are no Roman numerals inside the formulas. That's just regular letters and numbers. And there are no real numbers inside the names. This is the only place where we'd use a Roman numeral. So you have another worksheet that's going to practice times when you need Roman numerals. Some of them will, some of them won't. If your element, if your metal comes from one of the tall columns, columns 1, 2, 3, or 4, it probably won't need one. Lead and tin out of column 4, so Pb and Sn are 2 exceptions. Otherwise, almost all metals from the tall columns have one charge only. If your metal comes from the middle section, the transition metals. The transition metals almost all have more than one charge and will require Roman numerals.